Okay. Zoom went down. I hope it stays up for a while, but. What do we do with this? And actually, I should say here, let's expand this. Now, this is an intermediate algebra because we're into properties of exponents and so forth. What's this? Well, we use the distributive law. So I'm going to say that this is 3x squared y to the fifth multiplied by x squared y to the negative third plus 4k squared minus 2zk times x squared y to the negative third plus 4k squared. Not writing this particularly well, right too fast. Okay. In other words, it's this times all this minus this times all this. That's an instance of the distributive law. I use the distributive law once more, multiply this by this, then plus this times this, and so forth over here. This is going to give us 3x squared y to the fifth times x squared y to the negative third plus 3x squared y to the fifth times 4k squared. And I don't have room to get everything on this line, so I'm going to do this. We have minus 2zk times x squared y to the negative third minus 2zk times 4k squared. Okay, well, that's an application of the distributive law. What we're really getting at now is something that's a little bit new in intermediate algebra, where we have to deal with these exponents. Now, this is often done also in elementary algebra, but officially, this is now intermediate algebra. So how do we multiply this out? Well, we get 3 times x squared times, well, x squared times x squared is x to the 2 plus 2, because when you multiply the same base, two numbers with the same base and different and exponents, you add the exponents. And we've been over in detail why that works. And then we got y to the 5 and minus 3, because the exponents of y are 5 and minus 3. Okay, well, applying the same rules, we don't have any like terms here. Okay, there are no x's or y's over here, so we can just write this out. 3 times 4 is 12. And then we have x squared y to the fifth k squared. Then that's minus k2zk times all this. Again, there are no z's or k's over here, so we're just going to have negative 2zk x squared y to the negative third. And then it's minus 2zk times 4k squared. Well, minus 2 times 4 is minus 8. And then z is not multiplied by anything over here. And we have k times k squared, which is k times 1 plus 3. So this is an application of our rule for multiplying the same base, for multiplying two expressions with the same base and with some exponents. Okay. So now we get 3x to the fourth, y to the second, 5 minus 3 is 2. And then 12 plus x squared y to the fifth, k squared. And then minus 2 zk x squared y to the negative 3. And then minus 8zk to the 1 plus 3. And you know, it isn't 1 plus 3, it's k squared. Should have been 1 plus 2. So it's minus 8zk to the third. Now we have at least one negative exponent here. So we could write this as 3x to the 4th y squared plus 12x squared y to the 5th k squared minus 2zk x squared over y cubed minus 8zk cubed. So we have a fairly complicated expression. What you see in a test will probably not be quite that complicated, but you should understand all these steps and be able to do a problem of this nature. And if you can probably handle most of what you're going to get as far as rules for exponents. Maybe not everything, but you should be in pretty good shape if you can do a problem of this nature. Okay, so for a factor, 8x to the 4th, y to the 5th, minus 12x squared y to the 7th. So I want to factor out the greatest common factor. Greatest common factor. Well, the greatest common factor of 8 and 12 is 4. 4 divides 8, 4 divides 12. Okay. Nothing bigger divides both of these. 12 doesn't divide 8 and so forth. Okay. Now we have x to the 4th and x squared. Well, the greatest of those is x squared. The highest power of x we have in common is x squared. And the highest power of y we have in common is the 5th power, so it's y to the 5th. So we're going to write this as 4x squared y to the 5th multiplied by whatever else we need in order to get these two terms. Now, to get the first term, we have 4 here, we need 8, so we better have a 2. So if I multiply this by this, I at least get the 8. Now I'm going to need some x's because I've got an x squared here and an x to the 4th here. What do I have to multiply by x squared to get x to the 4th? Well, it should be clear that x squared times x squared is x to the 4th. And I already have y to the 5th here, so I don't need anything more. If I multiply this by 2x squared, I'm going to get this. Again, 4 times 2 gives me 8. X squared times x squared gives me x to the 4th. So when I multiply this, I'm going to have this term. Now I have to do something similar over here. Well, to have 4, we need negative 12. What would I multiply 4 by in order to get negative 12? Well, that would be negative 3. So 4 times negative 3 is going to give me my 12. I've got an x squared here. I need an x squared here. Well, I've already got it since I have the x squared. So I don't need any x's. Okay, now what do I have here? I've got y to the 5th, but I need y to the 7th. So I'm going to need y squared. That's it. Now to check, I multiply this back, but I've already kind of done that by pointing at it. But you should multiply that out and make sure you can extract the greatest common factor. Okay. Now we also factor trinomials. let's factor x squared minus 3x minus 18. I think that ought to work. Okay. Now, we can try all possible factors. Now, there are shortcuts to this, but it comes down to what I'm about to say here. Okay. We can use x minus 1 times x plus 18. That would give us a minus 18. Now, when we use the distributive law and multiply this out, we're going to have a negative 1x and an 18x. That ain't going to multiply out. That's not going to give us 3x. Okay. So I'm going to eliminate that possibility, and I'm going to use something different. Now, I could also put the 18 here and the 1 here. It would be, turns out it'd be the same thing, so I wouldn't do that. Okay. What else multiplies out to give us negative 18? Well, I could use x minus 2 and x plus 9. And what I just said about it didn't make any difference. It did, kind of ignore that for the moment, you'll see. Okay, x minus 2 times x plus 9. Negative 2 times 9 gives negative 18, but negative 2x and 9x don't add up to negative 3x. Matter of fact, we have to have a negative here, so it would have been more reasonable to try x minus 9 times x plus 2, because then I'd know that I'm getting a bigger negative than a positive. Still, that's not going to give me negative 3x. I'm going to have negative 9x and 2x. That's going to give me negative 7x instead of negative 3x. Okay, well, let's try x minus 3 times x plus 6. We wouldn't really try that if we were thinking, because the positive here is greater than the negative, and we're not going to get a negative 3x out of that. But if we do this, we see that this is going to give us x squared plus 3x minus 18. And now if I reverse where the 6 is and the 3, it should be clear that we get x squared minus 3x plus 18. Okay. Okay. Now, if we want to factor this, it's a bit of a can of worms. Okay. 6 could be 1 times 6 or 2 times 3. So we could have 6x here and x here, and then we've got to fill in factors that give us negative 10. Okay, well, we can do that. Okay, we could have 6x minus 1, x plus 10. We could have 6x plus 10 times x minus 1. And it would make a difference. This is different than this because we have different coefficients in front of x this time. Okay. 6x plus 2 times x minus 5, or 6x. Actually, I'm not listing all possibilities. Okay? Let me flesh this out. Okay, here I've got a minus on the 1. I could also have a plus on the 1 and a minus on the 10. I have 6x, then plus 1 times x minus 10. 6x plus 10 times x minus 1. These are all possibilities that'll give us 6x squared, and they'll give us negative 1. And then we could have 3x minus 1 and 2x plus 10. or 3x plus 10 and 2x minus 1, or 3x plus 1 times 2x minus 10, or 3x minus 10 times 2x plus 1. There are 8 possibilities here, and they all give us 6x squared, and they all give us negative 10. One of these is going to give us plus 11. So which one is that actually? Yeah, okay, some will. Okay, we don't have time to do it all. Let's see if I can find it real quick. It's going to be one that has a plus, so we're going to have a plus 10. I don't know if this even works out. I'm having trouble finding one that, oh yeah. And we've got 8 more possibilities. Because 10 could be 2 times 5. So we've got 6x minus 2 times x plus 5, or 6x plus 5 times x minus 2, etc. Are going to be 8 more of these. Okay, well, Open Math gives you alternatives to make this a little bit easier, but at the very least, you should be able to, if you're totally desperate, list all these possibilities, eliminate a lot of them. Like, I can pretty much eliminate all of these possibilities. Okay. There's no way I'm getting 11 out of these. I can see by looking at the numbers, if you look at them a little closer, pretty sure you'll see the same thing. One of these ought to work. Okay, well, we're out of time. I'll review a little bit more next time, but that'll be the first of next week. I'll be sending out practice problems and problems that you can work on, scan, send to me so I can see your work. Okay. And I really need, in order to give you much help, to see more of your work. Okay, especially if you're in the category of getting pretty much everything right on your homework, but have a pattern of not performing well on the tests. Now, there are some people who are performing very well to fairly well on the test, but it's not the majority. So put yourself in a position where I can give you some help, please.